Look at this car. It was just totaled in a crash. It will never drive again. And right now it is sitting in a salvage yard somewhere in America, waiting to get crushed. But here is what nobody is telling you. The battery pack inside that car still has 70 to 80% of its original capacity left, enough to power your entire home for a day and a half straight. And it is about to get thrown away. Meanwhile, you are out here considering spending $15,000 on a Tesla Powerwall 3. Same technology, same basic principle. One has a Tesla logo on it. The other one is sitting in a junkyard waiting to be shredded. The Second Life EV battery market is already worth nearly $1 billion today and is projected to hit $20 billion by 2033. The big energy companies know this. The engineers know this. But you, the person writing that monthly electric bill check, have never heard a word about it. So why is that? Drop one word in the comments right now. Would you actually do this? Type yes or no. I read every single one. Here's the question nobody in the energy industry wants you to ask. If a battery that still holds 80% of its original power can be repurposed at a fraction of the cost of a brand new unit, why is there no major retailer selling this? Why has your solar installer never once brought it up? Follow the money. The home battery market is built entirely around selling you something new. A company like Tesla makes its margins on new hardware, new installations, and ongoing service contracts. A battery that costs almost nothing to source and takes years to wear out completely does not generate recurring revenue for anyone, so nobody with a marketing budget is going to educate you about it. McKinsey projected that Second Life EV battery prices would fall to just 30 to 70% of the cost of new batteries by 2025. But the supply chain to get those batteries into American homes barely exists yet. And there is no widely accepted safety standard specifically for repurposed lithium-ion batteries in homes. That gap does not mean the technology is dangerous. It means the industry has not been forced to make it easy for you. Those are two completely different things. During World War II, the U.S. military routinely pulled batteries from damaged vehicles and rewired them to power field camp. Here is the simple science behind why this works. An EV battery is a giant, portable electricity warehouse. Inside a car, it needs to discharge massive power very fast to accelerate a 2-ton vehicle from 0 to 60 miles per hour. That is an extremely demanding job. After 8 to 10 years of that work, the battery can no longer do it fast enough to give you acceptable driving range. But your house does not need that kind of power. Your refrigerator, your lights, your router, your air conditioning unit, these are slow and steady loads. A battery that can no longer sprint is still perfectly capable of walking. And walking is exactly what a home energy system needs. The numbers confirm this. When EV batteries reach end of automotive life, they still retain approximately 80% of their original energy capacity. A used Nissan Leaf with a 40 kilowatt-hour pack still holds roughly 28 to 32 kilowatt-hours of usable storage. The average American home uses about 30 kilowatt-hours per day. Do that math. A company called Repurpose Energy, founded by UC Davis engineers, received nearly $10 million in grants and delivered its first commercial Second Life battery unit to Nissan USA in 2024. This is real infrastructure being built right now, not a garage experiment. Let us talk actual dollars. A Tesla Powerwall 3 fully installed in the United States in 2026 runs between $11,500 and $16,500 depending on your location and installer. At 13.5 kilowatt-hours of storage, that works out to roughly $1,100 to $1,200 per kilowatt-hour. Now here is the alternative. According to peer-reviewed research, Second Life EV battery systems can be sourced and assembled for between $44 and $180 per kilowatt-hour of storage. Even at the high end of that range, you are looking at a cost 6 to 7 times lower than a brand new Powerwall. Redwood Materials, co-founded by a former Tesla executive, publicly stated its Second Life installations cost less than $150 per kilowatt-hour today for systems that deliver power over 24 to 48 hours straight. For a realistic DIY build, using a salvaged Nissan Leaf 40 kilowatt-hour pack, here is the actual breakdown. Battery pack sourced from auction or salvage yard, between $1,500 and $3,000, depending on condition. Battery management system plus inverter plus hardware, between $800 and $1,500. Total build cost, roughly $2,300 to $4,500 for approximately 28 kilowatt hours of usable storage. Compare that to $15,000 or more for 13.5 kilowatt hours from Tesla. B2 U-Storage Solutions already operates a 25 megawatt-hour facility in Lancaster, California, running on 1,300 Second Life EV battery packs. That is a functioning commercial power plant built entirely on batteries the industry considered dead. Here is the real-world process, step by step. No hype, no shortcuts. Step 1. Choose the right chemistry. Not all EV batteries are equal for home use. The best choice is LFP, which stands for lithium iron phosphate. LFP handles more daily charge cycles, tolerates sitting at full charge longer, and is far more thermally stable than other lithium chemistries. Nissan Leaf packs from 2018 onward are among the most practical options for this reason. Avoid older NMC packs, nickel manganese cobalt, for stationary home use. They work well in cars, but are less forgiving when cycling every single day in a fixed setup. Step 2. Verify the battery health before you buy anything. This step is non-negotiable. You need to check the state of health, or SOH, of any pack you consider. Target a minimum of 70% SOH. For Nissan Leaf packs, a free app called Leaf Spy paired with a $20 OBD2 Bluetooth adapter gives you a full health readout in minutes. Step 3. Use the right protection hardware. A Second Life battery needs a dedicated battery management system built for stationary use. The original car, BMS, was designed for the vehicle's systems, not your home grid. A proper stationary BMS monitors cell voltage, temperature, and current in real time and shuts the system down before anything goes wrong. You also need a hybrid or off-grid inverter to convert DC battery power into AC power for your home. Now the honest part. And this matters. This is not a plug-and-play weekend project. The voltage inside a 40 kilowatt-hour pack is high enough to kill. Research from Newcastle University, commissioned by the UK government, found that thermal runaway risk increases significantly when a pack's full history is unknown and cell-level monitoring is absent. The good news is that LFP chemistry has a thermal runaway threshold of around 270 degrees Celsius, dramatically higher than other lithium types. A quality BMS makes this risk extremely low, but extremely low is not zero, and you need to respect that. Check your local codes. In the US, repurposed battery systems fall under UL 1974. Check with your insurer before installation. If you do not have a solid DC electrical background, hire a professional. The economics still work in your favor with labor factored in. Here is the big picture. Battery prices for new lithium iron phosphate cells dropped from $535 per kilowatt hour in 2013 to $78 per kilowatt hour in 2024. That is an 85% reduction in just over a decade. And the number of EV batteries reaching end of automotive life is about to surge. Over 200 gigawatt hours of EV packs will retire by 2030, enough to meet 30% of global grid storage demand. Most of that will go to commercial operators or recycling facilities unless regular homeowners know to look for it. 3 things you can do this week. Search for Second Life EV battery installers in your state. If you own an older EV facing a battery swap, get the old pack tested before the dealer disposes of it. And if you are pricing home backup power, ask your installer specifically about Second Life options alongside new hardware quotes. This channel exists to get real energy information to real people. Not the version that ends with a sales pitch. 3 things to remember from today. 1. A retired EV battery still holds up to 80% of its original capacity. Real energy is being thrown away every single day. 2. The cost gap between a Second Life system and a brand new Powerwall is 6 to 7 times. The performance gap for home storage is almost nothing. 3. LFP chemistry plus a proper BMS plus either professional installation or real electrical knowledge equals a safe and cost-effective system. Do not skip any of those 3. Tell me in the comments what is stopping you right now. Safety? Technical complexity? Not knowing where to find the batteries? Your answer decides what this channel covers next. Because the next video, pairing this setup with a self-installed solar array for under $500. That one is going to change how you think about your electric bill permanently. See you there.